Well, good afternoon, everybody. My name is Brian Moore, and I'm the Senior Vice President of Global Sales and Marketing here at Conducive Technologies, and happy to be your host and moderator for today. But we're not just talking about Conducive and what our solution is doing. We also have on the line with us a trusted vendor of ours that we partner with, Nimble Storage. And I do have a couple of representatives from that side. One of them is Eric Heinrichs, SE with Nimble Storage, and also Patrick, who runs the, I believe, Patrick, you run the Southern California region for Nimble, is that right? In fact, Patrick, I don't know if we even had you join in as a panelist to even speak. So, Eric, do you want to chime in and say hi to the audience?
Really appreciate the opportunity to be on today.
As you can see, he's not necessarily a man of many words, keeping it short and succinct, just as people want to hear on a webinar already. And also on the line with us is a customer of both Conducive Technologies and Nimble Storage, who we're actually highlighting in this webinar, someone who has taken a best-of-breed approach to handle I/O performance in his virtual environment in the best way possible, at least from a cost per performance standpoint. In fact, and that would be Jamie Rabenstein. And Jamie, why don't you chime in and say hi to our audience?
Hey, everybody. I'm glad you're here. Excited to tell you about how we have used these products and what they're doing for us.
In fact, Jamie, TechTarget recently featured you in an article on taking this best-of-breed approach for I/O performance in their environment, didn't they?
Yeah, they did.
Well, we can hear a little bit about some of that firsthand. We hope that you're getting settled in with your lunch right now. I would just want to mention, if for any reason you haven't received your lunch, just write something in the chat box and address it to the host. You can see Conducive Technologies. We have a team sitting on the edge of their seat that can make sure they uncover the status of where your pizza is and let you know if it's on your way, if for some reason that there has been any delay. I do want to let you know that this is going to be an audience-driven webinar, as we like participation as much as possible. So you can see the bottom right-hand side, the Q&A box right there. That bottom right-hand side Q&A box, any question that you have as we go along, just type that into the Q&A box and address it to all panelists, and we'll address that either as we go along or, and we'll absolutely make sure we get to it when we get to the bottom of the hour and move to a full Q&A session. And we'll stay on as long with you for as long as any of you have questions. So right now the agenda for today's webinar is I'm just going to share with you a high level about Conducive Technologies and what V-locity I/O reduction software does for customers. And then at that point, Eric, the SC with Nimble Storage, he'll chime in and give you just a really quick high level, big picture of why people are using Nimble Storage. And then we'll do a little Q&A interview with Jamie for 10 minutes as we reach the bottom of the hour, who can talk about how he combined both solutions to get an end-to-end best-of-breed approach for handling I/O performance. That is, using Nimble for his back-end storage solution for handling IOPS and throughput for as cost-effectively, for as much cost per performance as possible, while also using at the same time V-locity I/O reduction software at the VMOS layer to address the I/O inefficiencies in virtual environments to offload some of the unnecessary IOP bandwidth that otherwise gets pushed down to the underlying storage device, stealing IOPS and cutting into available throughput. So if you jump over with me and you look on your screen, you can just see the opening slide that just tells you who we are, Conducive Technologies. I don't like to spend a lot of time on this slide. It's just to let you know that we have history and credibility, 34 years in business, 12th oldest software company in the world, and some of the recent accolades for what we've been doing to improve I/O performance in virtual environments with our I/O reduction software solutions. Our customers see anywhere from 50 to 300% faster performance using our software at the VMOS layer. That's why you've seen accolades like Gartner Cool Vendor, Storage Magazine Storage Product of the Year. We have, we're OEM by 9 of the top 10 PC manufacturers in the world, the Western Digitals and SanDisk of the world, and have close relationships, as you can see, with both Microsoft and VMware. So I'm going to advance to slide 4. If you take a look in front of you, we call these the 2 silent killers of VM performance. Now, virtualization has been absolutely fantastic for your server efficiency. But here's the dirty little secret about virtualization, and it's this. It adds complexity to the data path. So due to this added complexity, virtualization breaks down the I/O characteristics of your workloads to be much smaller, more fractured, and more random than they need to be. And as you can see, there's really 2 big I/O inefficiencies that create that problem of your I/O characteristics breaking down. One of those is on the right, the I/O blender effect. You may have heard of that before. What it is it's an issue where you have disparate VMs on the same host or hypervisor. From the VM to the host hypervisor, your I/O traffic is sequential in nature. But once those disparate VMs, once their I/O traffic hits that host hypervisor, it's then subsequently intermingled or blended or mixed together. So from the host hypervisor down to storage, you don't get sequential I/O patterns. You get random I/O patterns, which is much more difficult for your storage subsystem to process, a phenomenon that's not true in a physical server environment, but very true in your virtual environment. But that's not the only tax of your to your performance in a virtual environment. There's a second tax called the Windows I/O tax. So Windows write inefficiencies are a huge problem in virtual environments. Now, what's interesting about this problem with Windows is that it's not a problem on day one. On day one of a fresh, new, clean NTFS install, you'll get good, clean performance, nice, healthy relationship between I/O and data, from that VMOS layer all the way down to the storage layer. But since Windows isn't very intelligent about how it writes files at the logical disk layer, which is the file system layer outside the SANS control, what happens after it writes files, erases files, rewrites files, and extends files, you get a lot of free space fragmentation at that logical disk layer. What happens is that a single file, let's say a 32K file, that should be written and read as a single I/O and will be written and read as a single I/O on day one, over time that relationship begins to break down. So what happens, because Windows is never looking for the right allocation to write a file, it's only looking for the next available allocation, that 32K file that should be written and read as a single I/O will end up getting broken down into maybe 4 8K chunks or 8 4K chunks. So one file that should be written and read as a single I/O will ultimately take 4 or 8 I/O to process the exact same amount of data. What happens is both of these problems compound against each other. So you're not just getting small fractured I/O from the Windows OS side, and you're not just getting randomization of I/O from the I/O blender effect. Together, they're compounding the problem with each other. So you end up with a surplus of small fractured random I/O. And what this means is your systems are processing workloads about 50% slower than they should, because your system performance is suffering death by 1,000 cuts from all this small, tiny, random I/O. You're not getting nearly the throughput you should and are much more IOPS dependent than you need to be. So even though virtualization adds complexity to the data path, native virtualization out of the box, it does absolutely nothing to solve this or compensate for it. That's why it's a dirty little secret, because your only choice ends up being to overbuy and over-provision for performance from a storage hardware standpoint. So our Velocity I/O reduction software solves this problem, and this is why our typical customer sees anywhere from 50 to 300% faster application performance on the hardware infrastructure they already have. In fact, we'll just give you an idea of what customer of ours see using our software. ESG Labs, an independent analyst group, examined the last 3,500 VMs that tested our software in a production environment at over 100 sites. And they published these results to show what our software does on average across all systems, because not all systems are taxed to the same degree with the problem of small fractured random I/O. But as you can see in front of you, this impacts at least half of those systems in a very demonstrable way, and about a third of those systems in a very, very big way. So here's the first thing you should notice. Over half of all systems that evaluate velocity see a 50% or more reduction in read I/O from VM to storage. But it's not just read I/O. It's also write I/O. As you can see, 27% of systems see a 33% or more reduction in write I/O. In fact, 14 of those systems are taxed so badly that they see a 50% or more decrease in write I/O. So when you add up all this read and write I/O that we are eliminating at the VMOS layer and offload that from the underlying storage system, you see that you'll get big improvements in throughput, response time, and IOPS. In fact, the next slide translates that. ESG Labs dug into that data to say across these 3,500 VMs, what was the net increase in throughput, improvements in throughput and latency and IOPS from that from our I/O reduction. And you can see in front of you the really big takeaway there on the top left. You can see that nearly half of all systems that test velocity see a 50% or more jump in throughput. In fact, 1/3 of systems are taxed so bad by the problem of small random fractured I/O, they get a 100% increase in throughput or more with our software. So as far as response time goes, you can see there on the right, we deliver on average a 40% decrease in I/O response time across all I/O on all systems. And here's the interesting one over here. 25% of systems actually get a 50% or more jump in IOPS. Now, you would think IOPS would go down with our solution because we're eliminating all that small, tiny I/O that's chewing up your system performance and stealing your throughput. But since we're improving the sequential nature of your I/O streams and serving some of that I/O from DRAM, IOPS actually goes up. So I'll just take you into the next slide and just very close to handing it off to Nimble here, but you may wonder, how can software drive these kinds of benefits in someone's environment? And it really is just simply because of two ways that we're able to drive that benefit. First is one side of our engine that optimizes writes. And when I say optimize writes, we help Windows VMs write files in a much more sequential fashion. So that means your writes and subsequent reads are going to be handled in a more sequential nature. So instead of needing maybe 80,000 I/O to process a gig of data, you may only need half that or even less. And the second thing that our software does is optimize reads using our DRAM read caching engine. You may not know this, but we're the world leader in caching technology. And the nice thing about our DRAM caching technology is you don't have to allocate anything for cache. It just simply uses the idle available DRAM that you already have. So we help organizations establish server-side DRAM as tier 0 for their caching strategy. And if you think that DRAM or available DRAM is too limited amount of capacity to have much impact, well, I think you see from the data that we put in front of you, it has an enormous impact. Over half of systems see 50% or more of their read I/O service from our caching algorithms using their available DRAM. And all I/O across all systems sees a 40% reduction in latency. And that's simply because we're application aware. We have a behavioral analytics engine that's very intelligent, so there's very little cache churn. And people forget that DRAM is 10 to 15 times faster than SSD. So it's actually the perfect place to satisfy your hottest read data server side. So with that, I'm going to, Eric, I'm just going to jump over. I was going to mention our conducive I/O assessment tool to help them. It's a free tool that helps them identify I/O inefficiencies in their environments. But we can maybe just talk about that at the end of the call. Let me hand it over to you, and you can talk about how people are using Nimble storage.
Literally transforming.
Eric, I don't know if you maybe are speaking but are muted out. You may have to unmute because we're not hearing you.
Oh, boy.
There you go.
Can you hear me now? Okay.
I can hear you now, Eric.
All right.
Just tell me what you need me to advance the slide.
Sure. No, I appreciate that. I apologize. Yeah, I was speaking on mute here. So I'll start over. First of all, thank you, everybody, for just the opportunity this afternoon to speak to you for a little bit just about Nimble and what we're doing in the marketplace and how we're really transforming data technology and the way data is stored and in terms of delivering unprecedented performance and capacity in a much smaller, efficient footprint. And we'll talk about the ways that we're doing that and really how our technology is very much complementary to the Conducive story. So with that, why don't we go ahead and go to that first slide, Brian, and we'll take a look at kind of the company overview here. So just real quick kind of snapshot into what our business looks like. We are a publicly traded company headquartered in San Jose. You can see the stats there. The customer number is actually around 7,000 now. This is a little bit of an older slide, unfortunately. The cool thing about, what we've been able to accomplish in a very short amount of time is, we've really only been shipping product for about 5 years. So the company is about 7 years old. Our first arrays were shipped out in April of 2010. And with that, we've been able to very rapidly grow. In fact, if you look at our trajectory, we're literally the fastest growing storage company historically based on how many customers we've been able to acquire in that time and how many total arrays have been sold. So we're hovering right around 12,000 arrays out there across those 7,000 unique customers or so. And the interesting thing is the recognition we've been able to get in the industry. Gartner has recognized us in the latest release, their Magic Quadrant for general purpose storage arrays as a leader. So we're in the upper right-hand corner amongst good company of, other companies that have been around for much longer than Nimble. So definitely check that out if you get a chance to. You can, look at the Gartner stats on that. But a lot of validation and accolades that we've received, again, in a very short amount of time. So let me go ahead and talk about the technology a little bit, just in the interest of time here. So fundamentally what we do, we brand ourselves as an adaptive flash platform. And what we mean by that is there's a lot of companies out there touting the capabilities of flash storage or SSD. Many of them are invoking methodologies based around tiering data. Typically what happens is you'll find a vendor that's been selling disk storage for many, many years. And oftentimes what they've done in an attempt to take advantage of the capabilities of flash is they're really bolting that on as a tier of storage on top of traditional disk technologies. And that works okay. To an extent, they're able to accelerate write operations while also servicing reads. But where it really breaks down is that tiering aspect of data management. There's always a time factor involved in tiering data. If I'm using a small amount of SSD for my incoming write operations as well as hot reads, not all of my data can live in that small tier of flash. So oftentimes what happens is there's time and effort involved in migrating that data, whether that's a manual process or even an automated process that most companies take advantage of to do that. We take a very different approach to that. We have a ground-up philosophy of how we actually manage data within the Nimble platform. And we'll break that down in a slide in a minute here. But in general, when you look at our architecture, it's a very flat architecture. We're literally leveraging the capabilities of high-capacity disk for what it is exceptionally good at, which is storing lots and lots of data at a very relatively low cost. And we're taking advantage of what SSD really shines at, which is accelerating read requests. So SSD for us and flash is 100% leveraged as a read cache, which we'll kind of break down, which again is very similar in ways to the way that Conducive actually manages data at the host level. And again, we really see ourselves as a complementary technology, to what V-locity offers, and we can kind of break down, that, and especially as our customer presenter talks about the fact that, what they're doing with both technologies, you kind of see where they both fit within the data center. But with that, again, where we see ourselves really playing in the marketplace, if you look at the pyramid there, we're not necessarily going to be the cheapest storage. If you're looking for, nearline kind of archival, cheap and deep storage, we're not necessarily going to play as well in that category, although we do have plenty of customers that use us as an archive or a backup target. But really it's kind of that 80%, the top part of the pyramid there, where you've got a lot of mixed workloads, a lot of performance-hungry applications where they need very low latency reads and writes. And again, using our adaptive flash methodology, we're able to very efficiently achieve both of those things at a relatively low cost point. So let's go ahead and go to the next slide, please. So a little bit about how our architecture works. So the acronym for our file system is, as you see there, is CASL, C-A-S-L, which stands for Cache Accelerated Sequential Layout. Don't worry, there won't be a quiz on that, but just to give you a little bit of an idea of what that's all about. The sequential layout portion of it really refers to how we write data. So if you look at the diagram on the right-hand side there, I know it's a little bit of an eye chart and it's kind of a small font, so I'll kind of walk you through the process. Basically, as I/O is written from applications, and this can be any application that you can think of, SQL Server, Exchange, Oracle, SAP, you name it, we're going to store those blocks very efficiently by aligning our block size to the way that the application natively writes. So let's say, for example, it's an ESX server and you're using vCenter or vSphere rather. vSphere uses a 4K block size. So we align to the block size. We have a performance profile that optimizes that. And what we'll do with those 4K writes is we'll combine those with every other incoming write, whether those be 8K or 32K IOs coming from different applications and mixed workloads. And while we're taking that random I/O, we're going to effectively use the CPU and memory in the controller, the DRAM essentially, to organize that data, coalesce that random data, and organize it into sequential data, and then compress that in line. When we do that, our data reduction factor on average is around 2x data reduction. So not only are we shrinking the data set that's being written, but we're also doing I/O consolidation. So similar to the way that velocity is actually reducing the I/O that's sent to the storage from the host side, we're actually taking all incoming writes from all applications, regardless of whether or not they're Windows-based, whether or not they're using velocity, and we can take that data, that random I/O, we can organize it into sequential I/O, compress that inline, and write that down to large capacity hard disks. Now, the interesting thing about writing to large capacity drives is if you see on the left there, we're not writing to 15K disks, we're not writing to SSD, we're literally writing to 7.2K nearline SAS drives. These are the largest drives on the market. They're also the least expensive. And the reason that we use this is by organizing the data and writing sequentially, transforming effectively random data into sequential data, we're able to drive a considerably higher amount of performance out of this commodity disk technology than what you typically see from our competitors. So as an example there, if you look on the left-hand side, our CS700 platform, which uses the most amount of RAM as well as the most CPU cores, we're able to literally derive double the I/O out of a single, 7.2K hard drive, as you would expect to see from a typical MLC drive. So an MLC SSD will yield on average about 5,000 IOPS, and we've been able to demonstrate repeatedly then on a 700 using a single 7.2K nearline hard disk, we can get upwards of 10,000 IOs out of that simply by organizing the data. So that's kind of the beauty of Castle and what we're doing by arranging data, taking this methodology of deriving performance from CPU and decoupling that from spindle. Every other system out there that I'm aware of, and I've been selling storage for over 10 years now, when you talk about I/O and deriving IOPS and for performance, typically what you're talking about is adding disk, right, and leveraging the capabilities of many, many hard drives working together and aggregating that combined I/O to deliver performance. With Nimble, we take a very different approach. We derive performance from CPU and memory and the way that we organize data while writing it to a very small footprint of spindles. Okay? So let's go ahead and go to the next slide, and we'll talk a little bit about how we read data. So this is leveraging the SSD as a cache. You'll notice on that first slide, we didn't talk at all about flash, and that's because SSD literally doesn't sit in the write path. Except for the fact that we're basically making a copy of the hottest data as it's being written to large capacity disks and caching that into flash. So the flash is there 100% to, as I said, accelerate read requests. And as you can see from the numbers on the right-hand side there, our averages are pretty impressive when you talk about latency, which is ultimately what we're really discussing here. It's not so much a conversation about IOPS or throughput as much as it is about latency, because that's ultimately what your end users are going to experience is, what is the latency involved in reading or writing data. These numbers, by the way, as you can see, if you can read the little writing there by the asterisk, this comes across our entire Nimble install base of over 12,000 unique arrays out there. Each of those arrays phones home daily and has every 5 minutes sends a heartbeat back to our kind of corporate headquarters. So we're able to extrapolate a tremendous amount of useful information from these arrays. And one of those statistics is what you see there, which is that our average latencies for both read and write across our entire install base are measurably under 1 millisecond in time. So in the interest of time here,
Patrick, this is Brian. I'll have to ask you to wrap it up pretty quick so we can get over to Jamie before the bottom of the hour.
Absolutely. Yeah, I've got one last slide that I'll end on, and I appreciate that. And that's just simply our scalability story. We can scale in any of three ways. Again, because we are able to effectively decouple performance from spindle, if you need to add capacity to a Nimble array, you simply do that by adding expansion and closures of disk. If you need to grow in performance independent of adding capacity, you can do that by cycling through our different controller architectures, as you see there on the left-hand side, from the bottom being the CS200 series, all the way up to our CS700, which is our flagship product, which is literally capable of delivering over 125,000 IOPS across 12 hard drives and 4 SSDs. So very phenomenal performance out of that array. And then lastly, if you need to scale in both performance and capacity, we also offer scale out, which allows us to combine multiple Nimble arrays into a single cluster. With that, I'm going to turn it back over to the Conducive team, and I appreciate your time, and we'll look forward to chatting with you more in the Q&A section at the end. Thank you.
Great. No, thanks, Eric. Really good description, and I think that our audience can really clearly understand how both of our technologies, complement each other, one from the top end of the stack, the other one from the bottom of the stack. Well, here's the guy who can talk in and speak to his experience about using both of these together, and that's Jamie Rabenstein, who works with Victor Treatment Center. In fact, Jamie, you were recently featured, as mentioned, in a TechTarget article. I believe it was their search storage portal, about how you combine both of these technologies for best-of-breed I/O performance solution. Is that right?
Correct, yeah.
And Jamie, maybe you could just share just a little bit first off for our audience. I know that they're going to really want to know this. Can you just describe your overall roles and responsibilities at Victor?
Yeah, definitely. Well, I was lucky to be able to put together everything that we have, so I've architected what we have, and I do that moving forward. I also manage the infrastructure itself, so we have a team of people, who do various tasks, but I kind of look over all that and make sure everything's doing what it's supposed to do.
Right. Now, I know that our audience, had to painfully sit through and listen to two different vendor pitches. Now they can actually speak to a technologist. And I encourage our audience, just chime in any questions that you have in the Q&A box. I see that a couple of them have come in so far, and we will address it at the bottom of the hour after our 10-minute Q&A session here with Jamie. But Jamie, first, maybe explain to our audience first, too, what are the heaviest applications that you have to support that are the toughest for you to support from an I/O performance standpoint?
Well, it used to be SQL. That was primary, foremost. After that was file services, just, basic, the needs of people getting to and from things and moving files around. But now that has rapidly changed to everything regarding virtual desktop infrastructure. So we have a VMware View environment, and right now we just broke to almost 300 desktops. I think we're at 298 today. By the end of the day, we might be at 300. We keep adding a few every day.
Well, I think that our audience can identify with both of those. One, obviously, historically, SQL being oftentimes the number one demand for I/O performance, but two, if they haven't rolled out a VDI initiative, they may be right there on the cusp of doing that. Now, Jamie, the challenge, though, for administrators is really it's staying on top of their I/O performance issues without breaking the bank. And you chose a two-tier approach to solving I/O issues. You chose one solution at the VM layer using V-locity to reduce I/O and eliminate the I/O inefficiencies in a virtual environment. And then you chose Nimble on the storage layer. So I guess first, why don't we start first on the top layer. Maybe we explain to our audience just a little bit about what V-locity does at the VM layer, and how have you seen it benefit your workloads in your real-world production environment?
Sure, thanks. In my kind of layman terms here, what velocity really does is make Windows smarter. And so when Windows goes to write, instead of just writing randomly anywhere in an open space, it does it in such a way where it's maximizing all the usage. And it's, I know Howard can explain this better, and maybe the other person. But what this really does is makes Windows smarter, makes it so that there's less writing, and the next time you read it, it's a smarter read also, and effectively makes Windows what it probably should have been from day one, which is writing where you should, and subsequently reading much more efficiently. So what that does for us, I mean, I kind of call it the velocity effect. After a certain amount of time with the velocity product installed, things just quiet down. IOs dramatically decrease. For us, I know you've said that some people's IOs increase, and for what we've seen in that is when something has to go fast, it has the ability to go really fast because it's not getting those split IOs in the way. And when something doesn't have to read or write very much, it does that more efficiently too because it's not kind of churning around and looking for things, with multiple reads and multiple writes. So it's really smartened our environment and quieted it down.
Right. And Jamie, if I said increase I/O, I misspoke. What I meant to say was that we increase I/O density, so you're getting a lot larger, more contiguous writes and subsequent reads that are flowing through that infrastructure in the first place. Now, Jamie, I had read from the Tech Target article that when you were using without velocity, you were monitoring using your storage UI to monitor your daily IOPS requirement. And after you've deployed velocity, your daily IOPS requirement demanded from your storage device went down by 38% on average.
Mm-hmm.
So I just want to ask you, how does that benefit? How would that be a benefit to other virtualized organizations?
Well, that was really before we even started doing VDI, so it's even more. I even have more information than the last time we talked. But I mean, 38% decrease in I/O is huge, meaning you have less congestion on your back end, whether it's iSCSI or Fiber Channel. It doesn't matter. You have less of everything going through. You're asking less of your underlying storage. So you're using less of the virtualized adapters in every virtual machine. You're using less of the real physical connections that go from point A to point B. So you're filling the pipe less. And when you really need a burst, that 38% is there for more overhead, more throughput when you really need it. But ultimately, it uses everything better.
That's a great point, Jamie. So now part two to this story is what you ended up doing on your back-end storage side to get yourself to a best-of-breed position on handling I/O performance in a virtual environment. I know you were using a different manufacturer's array before you went out shopping for a new array, and I know that you were looking at some different vendors, and then you ended up choosing Nimble. I'm sure it's the same exercise that a number of technologists listening in go through. Perhaps you can explain to the audience, that of all the storage arrays to choose from, why did you choose Nimble, and what has your experience been with it so far?
Sure. Well, after all the conversations we had with really the three big ones outside of Nimble, what we found is that all of those manufacturers wanted to deliver to us, a half a rack worth of stuff. So, 100 drives, a controller head, a secondary controller head. I mean, just, a whole different way of looking at storage, which is the older traditional way, minus the Castle operating system. And they really couldn't even give the performance specs and in the size and power consumption and ease of use as the Nimble. I mean, after we saw everything, there just wasn't another choice. We saw some that kind of looked like the Nimble from the outside, but they just didn't operate that way on the inside. And so that is a real good peace of mind for us now that we've had it for a little bit of time. We can't outrun it. In fact, I've got some new stats since the last time we talked, Brian. And we had some issues with a semantic installation on our almost 300 VDI desktops now, and it has tripled our I/O while we're in this testing phase. and having nothing to do with any product other than semantic alone.
Wow.
But the Nimble is just running like no problem. I mean, we're at about 10,000 I/O instead of 3, which is kind of freaking me out a little. But you know what? As of like 5 minutes ago when I took my latest readings, we are still at 99.75 cache hit ratio, pulling just under 10,000 I/O. 7,000 of those is read, which again is way outside of our norm. And we're still getting 0.34 read, 0.34 milliseconds, and 0.48 write. I mean, flying. And of course, I'm freaked out because it's doing a lot more than we want it to at the moment, and I know that it's a semantic thing, but it's such peace of mind that I'm not outrunning the hardware by a mile, and I'm really excited about that.
So it sounds like you have some performance insurance there.
Oh, totally. Oh, yeah. I know that the Nimble is never the problem, ever. We've had all kinds of other issues. Nimble's never the problem. It's the thing keeping us from having problems.
Right. And you're running not just your VDI workload on top of that Nimble. You're running all of your workloads on that Nimble device, aren't you? Everything we have is running on one Nimble and a backup DR Nimble at another data center. Everything that we have and care about is running on that. Yeah, and the great thing about that is nothing is feeling this. No virtual workload looks at this and goes, wow, things are slow today. I'm looking at it and being concerned, but the VMs, they're happy as a clam. They feel no performance decrease. Right. Well, super. Well, Jamie, that's fantastic. I think that helps our audience at least get in context of how both of these solutions together complement each other and the type of real-world experience that somebody is experiencing. I think that this is just kind of a side note before we move right into the Q&A, but maybe you could just describe your experience, what it's been like to work with each organization. It's one thing to just buy a product. It's another thing to actually work with an organization. How's been your experience with that so far? From both companies, it's been wonderful. Anytime I call tech support, I get, Johnny on the spot response, people who understand their not the typical tier one, let's think about it, let's do all the things, did you press the power button? I don't get any of those kind of things. I get people who understand, right away what I'm looking for and quick solutions. And so it's extremely beneficial. And if I don't understand something, I'll get a personalized walkthrough on whatever that is. So I have no issues at all with support, and it's been really great. Okay, fantastic. Well, Jamie, I really do appreciate you, and please stay on the line. We're moving to a Q&A session, and we'll allow our audience now to go ahead and jump in with questions. We did run just a little long beyond the bottom of the hour, but I think that we were able to get everything in. Our audience certainly hasn't left. I think we have everybody here who joined in initially. So if you do have a hard stop, we understand that you'd have to leave, but we are moving to a full Q&A. We have some great questions that came in. I have Howard Butler, SE, over here at Conducive, and he will help us with some of these questions, and we'll start moving through some of these. So if you do have a question, just mention if this question is for Jamie or if it's for Conducive or it's for Nimble, and I'll moderate through this the best I can, and we'll hold on here for as long as people have questions to ask. So let me first start off by a question came in from Tayward, and this is directed to Conducive. So, Howard, if you're there, you may want to unmute your line. He's asking, is the Conducive software, is it storage agnostic? For instance, does it work with SolidFire and others?
All right, Brian. Well, thanks very much for passing the ball over to me. And absolutely, the Conducive tools, whether they be the analysis tool, the assessment tool, or our solution set, the V-locity product, both are completely hardware and software agnostic. Simply put, if Windows sees it as a local NTFS volume, we're good to go. So it will work with SolidFire and others.
So in other words, and it doesn't matter what the storage media is, whether disk or spindles, because V-locity is handling the I/O inefficiencies that are occurring at the top of the stack.
Exactly right. Being at the top of the stack and optimizing or enhancing the behavior of how NTFS and how the file system works with it means that we're completely surrounded by Windows, and Windows supports all the underlying hardware storage below it.
Okay, now listen. Now one question I have here, and and this is shame on me for moderating this, but how can we engage with either Conducive or Nimble to learn more or to do a proof of concept? And I didn't even give any next steps or directions on that. So listen, with me on the line is our Regional Vice President of Sales for the West Coast. That would be Jennifer Joyce on the Conducive side, and that would be Patrick on the Nimble side. Jennifer, why don't you just go ahead, unmute and jump in, and if someone's wanting to engage either Conducive or Nimble, and as mentioned, get a little more information and move toward a proof of concept, how can they engage and how do they do that?
Yeah, absolutely. Thank you, Brian. No, we're very excited to work with anyone who would like to engage with us. And after the webinar, we will be sending out an email connection that you can reply to. Let us know what your interest level is, whether it's speaking with Nimble or Conducive or both, and we will certainly arrange a call with the proper resources for you. If you're local to us, we can also arrange on-site visits. One of the really key takeaways from this webinar as well, Brian, is going to be the Conducive Technologies I/O assessment tool, which will really give users an ability to take a look directly into the I/O deviation that's occurring at the VM level, and that's going to be a very comprehensive view into the environment and take it kind of out of theoretical conversation and give folks a really good understanding of what's occurring in their environments and what our combined or individual solution tool sets can do to help address that.
Okay, so in other words, if somebody, before they run headlong into a full-fledged proof of concept, you have a free I/O assessment tool that they can simply run in their environment that will do some performance troubleshooting and analysis and identify the types of I/O inefficiencies that exist in their environment and which systems are experiencing deviations in performance metrics that need help.
Yep, exactly.
Okay. Well, super, and this also goes to Stephen's question, can we get a copy of the slides or recording of the presentation? And I believe in the follow-up email, you will be receiving both of those. So let me go back to some of the questions that have come in so far, and we'll address those one by one as we move through. Let me see. This one is from Bobby Lee, and Howard, this one is for you about velocity, knowing that if optimization is being done on the server side to reduce I/O, he's assuming you must be leveraging CPU. So in this case, how much is velocity taxing the CPU? So maybe you can speak a little bit to some of the server overhead concerns that Bobby might be having.
All right. Excellent question, Bobby. So velocity employs a patented technology called invisitasking, which guarantees that we're only allowed to use system resources, whether they be memory, CPU, disk I/O activity, only the resources that are idle and free or available. We employ really a near zero overhead type of footprint. The solution is devised as a very thinly filtered type of storage device driver to optimize the behavior of how the file system interacts with writing the data down to the storage. So Windows is completely in control of the I/O and is not going to spend any additional CPU resources trying to manage that.
Yeah, thanks, Howard. I think it's to be noted, we're not doing anything CPU intensive. We're not coalescing or doing any write buffering. We're just simply supplying intelligence to Windows about the best allocation to write files at the logical disk layer, yet the file system level outside the SAN. So negligible overhead. Let me ask here, let me find one for, I have a couple here Conducive related, but let me see if I can find one that's Nimble related. And this one comes from On. He says that his company, and Eric, this will be for you, is in the process of testing with Fusion I/O for their SQL Server. He's asking, is this the same product as Nimble? So I'm not sure, perhaps he confused you as being a PCIe flash solution, I'm not sure.
Right. No, so great question. So Fusion I/O, really where we see them playing, in the marketplace. So I guess the quick answer is no, we're not the same. Fusion I/O really, focuses on, server-side acceleration of read requests. So it sits on the PCI bus. it's a card that goes in the host. Now, some of their newer products, I know they were acquired by, SanDisk, and, so some of their newer products, I think, do leverage some, external gear as well. But the core, that I know about Fusion.io is just really, generally aimed at specific workloads that would more or less be confined to a single server host. The difference with Nimble is we're literally a shared storage array. So just like, other arrays out there that you may be familiar with, we connect via iSCSI or fiber channel to the network and are able to service, storage for multiple applications, ESX farms, different, Windows applications and so forth, where really we're accelerating performance for all workloads regardless of which host that workload may live on. So it's really the difference of kind of stranded, performance versus shared performance, where we can, produce very low latency reads and writes to a whole host of applications across the data center.
Great. Thanks, Eric. Now, a couple more questions, Howard, that are actually over to you. And this one is from Daniel. He wants to know, how do you guarantee the integrity of disk writes when you're intercepting them at the OS level, with your software? It sounds like he's concerned about, potential data risk, that there may be a data integrity or data corruption issue. So how do we guarantee the integrity of writes if we're doing some optimization at the OS level?
Well, first of all, the writes are written directly or straight across to the storage. What we are providing is the information that the Windows NTFS file system needs in order to select the more appropriate contiguous segment of space to write the data in the least number of I/O requests. So the writes occur as they normally would, with or without our software. It's just in a more intelligent fashion. So we provide that bit of information to Windows, and it still handles writing the data as it normally would. On the read side, we do cache those reads in DRAM on the server side, and when those reads are modified, it's a direct write-through type of cache. So there's no coalescing or holding on to any data, so your environment is, 100% safe with or without velocity in terms of reading and writing its data.
So in other words, Howard, the important point to be made here is that velocity is not intercepting any of these. It's simply providing intelligence to the file system to help it choose the best allocation to write a file instead of the next available allocation, which is what creates that surplus of all that small, tiny, fractured I/O as that file gets broken apart.
Exactly correct.
So Bobby Lee has a follow-up to what you had mentioned earlier, and he said, hey, Howard, if resources are needed and grabbed by velocity only when those resources are idle, he said, hey, what happens if my server is constantly active?
Well, that would throttle back or may prevent velocity from doing as much as it potentially could. But from my vast experience in looking at thousands and thousands of systems, most systems have an abundance of CPU and memory that's not even being used. So why not trade that resource and put it to good use? The real question becomes, what if we are using that resource and something changes in your environment where that resource is needed by somebody else? Well, that triggers or causes velocity to recognize, wow, that resource is getting in shorter supply. Let's give it back to Windows before it reaches a memory or CPU type of activity of concern. So we're very dynamic, very fluid, and for giving back to the system.
And the important point to be made there is that even the resources that we are using were extremely, extremely lightweight. We're not doing any types of optimizations that are CPU intensive, like buffering, like coalescing. All that this is merely providing intelligence back. I know that we've worked with different customers who have monitored closely their systems, say whenever Velocity is doing their optimizations, they've seen CPU utilization jump by maybe 2%. But that's going to vary to the environment. But it's a very, very lightweight approach to optimizing your I/O.
Yeah, as far as the overhead, with V-locity, it would be very challenging for anyone to actually measure the any type of overhead. It's very lightweight, as you described, and the reality is, if you're incurring a huge penalty in split IOs, there's a phenomenal amount of wasted CPU overhead associated with just that task alone. So by carving that out and eliminating that Windows overhead, you gain back any type of CPU usage that you might have seen with our solution set in place.
So, Howard, I have another one for you. This is from Aaron, and he's looking just down the road. He just wants to know, hey, this Windows I/O tax that you're talking about, is this seen on REFS as well, or is it only NTFS? And does that even matter in a virtual environment?
Yeah, I mean, with every file system, whether it's NTFS or REFS, there are trade-offs in file system designs associated with either performance, reliability, or efficiency. Now, while there have been improvements in REFS, the fact remains that it still does suffer from the Windows I/O tax. You're not going to get away from it by switching to a different file system design. And there are just things that naturally need to be taken into account to optimize the behavior of I/O traffic streams at the point of where that I/O begins its journey, which is really within the guest OS.
Well, that's great, Howard. Thank you. I'm looking through my Q&A box, and I'm not seeing anything else that has come in for me or for anyone else that's sitting on the panel, unless somebody else has received something or received something through the chat box directly to you. If you have, please chime in. We do have one question here, and this is, Howard, this would be for you. Is Conducive, is it software, is this installed and operating at the VM level, or is this at the host level?
Right now, it's at the guest VM level, running within the Windows operating system.
Great, thank you. Well, and Howard and Eric, that's all the questions that I see from my end. What I want to do is I just want to allow Jennifer to chime in, at least on the sales engagement side, on Conducive. And Jennifer, I don't know if Patrick is on the line or not. I didn't look at the panelists to speak on the Nimble side, but Jennifer, why don't you just speak for closing remarks on how to engage with you, and then I'll hand it over to Patrick or Eric to give their closing remarks on engagement on their side.
Yeah, absolutely. Thank you, Brian. And I just wanted to thank everybody for attending the call today, and Eric from Nimble being able to attend as well. Really tremendous. And also, Jamie, we really appreciate you providing the context and color to the real-world application of these technologies in tandem. One of the reasons that we actually came together and co-hosted this webinar was really because of customers like Jamie. In my territory alone, I had conversations with at least 10, if not more, Nimble users who were also V-locity customers, and I just kept hearing these, one rave story after another of both technologies independently, and then wow, when we put them together, my gosh. And it just so happened that around the time that these synergies were really bubbling up, I really paid attention because I was just getting it organically from so many different places. So I sought out relationships with my counterparts locally with Nimble, and lo and behold, they had been sort of starting to hear the same types of things. And then we had Jamie actually attended VMworld and was able to meet with our executive team there, and now you're being able to participate and benefit from his experiences in our webinar today. So we were very excited, looking forward to providing the level of service that each of you attending today would be looking forward to, whether that's the Conducive I/O assessment tool, follow-up WebEx, or on-site visit. We'll be more than happy to accommodate that. And Brian, those are my comments and remarks, and I'll turn it back over to you. Eric is the representative from Nimble today who will be making closing comments for Nimble's side.
Sure, yeah. And Eric, if you can, did a great job giving just a quick overview of your technology. I know that that's such a difficult thing to do, especially for an SE. But if you can, please chime in and give your closing remarks and how we can work through engagement together.
Sure. No, I appreciate that. Thank you. Yeah. So, from our perspective, we love engaging, one-on-one with potential customers that are interested in going deeper, with Nimble. Our philosophy is, if a picture is, worth 1,000 words, then, a live demo is probably worth, a lot more than that. So we would love to come in, bring an array in. We're actually one of those companies that still, loves to bring in a box and let you kind of get that whole experience of being able to touch and feel the technology if you want to go that route. And one of the reasons we do that is, we do make such, kind of bold claims in terms of what we're able to do and what we're able to accomplish with a very modest and, meager amount of physical hardware, that for us to come in and show you in a live demonstration, being able to, demonstrate 15, 20,000 IOPS in a little, demo array that we carry around in our trunk is typically kind of the icing on the cake that for a lot of people, turns that light bulb on and says, okay, I get it now. I can see what you guys are talking about and how you're able to really, do what you say you can do. So love to do that for you if you'd like to. Other than that, Patrick and I are in Southern California. We're local here, and, we'd love to just come meet with you, just put a face with a name and talk to you a little bit more about your business and, what problems you're trying to solve.
Okay. No, great wrapper. Thanks, Eric. On had one final question, said, hey, Brian, will you send us the contact details for the reps and the presentation to the attendees? And the answer to that is yes. Not long after this webinar is closed, you will be receiving an email. I believe that email will be coming from Jennifer Joyce. It will contain a link to the presentation. That's on the Conducive side, but she will also be there to set up a meeting with you if you want to chat and explore more, and then also make that connection with the Nimble side as well. So with that said, I'd really like to thank our special guest, and that's Jamie Ravenstein, joining in from Victor Treatment Center, taking time from his busy day to explain a little bit about his experience combining best-of-breed approaches for IO performance. Surely do appreciate his input and words there. We thank everyone who took time for lunch, and we hope to be talking with you soon. So with that, thank you, and we'll speak to you soon. Thanks, Eric. Thanks, Jamie.
Thank you.
Yep, thank you.